Design Notes is a show about creative work and what it teaches us. I'm your host, Liam Spratham. Each episode, I speak with folks from unique creative fields to discover what inspires and unites us in our work. This episode, I'm continuing with our special series celebrating 10 years since the launch of material design, which explores the inception, evolution, and future of Google's design system. This time, I sat down with Adrian Secord, who describes himself as a roving engineer. Adrian has more than a decade of experience building systems and tools that transform design into robust product engineering at Google scale, and a PhD in computer graphics, too. In the interview, we dug into the perceptual qualities of design, why every engineer should experience a design crit, and why, designers probably should code, too. Let's get started. Adrian, welcome to Design Notes.
Hey, Liam, it's so nice to see you. Thank you so much for having me.
Yeah, I'm really excited to have you on. I want to start the episode the same way that we always do, which is to talk a little bit about who you are, what you're working on, and the kind of journey that led you there.
Yeah, for sure. So I'm an engineer, unlike a lot of people I'm working with who are, designers and design-oriented. Been hanging out on material design for about 10 years now. In fact, it was really fun listening to you talk to Will Larsh in the other episode because he and I overlapped heavily for a long time. So it was sort of fun to hear him talking about the past. Before I came to Google, I was doing a lot of grad school. I have a PhD in computer graphics, so algorithms for movies and video games and that kind of stuff. Never used any of that information. Never used any of that knowledge. Instead, joined a startup like many people did. And then, like many startups, it fell apart and was sort of purchased quickly by Microsoft. And I didn't want to go to Microsoft. I didn't want to leave New York. So ended up jumping over to Google and joined Google Wallet. And I was an iOS engineer on Google Wallet for a few years. And during that time, I started teaching an Intro to iOS course at Google. And so during that point, I met some people who are working on material design from the engineering side of things. And as I'm sure you know, the original material didn't really have a lot of engineering, or it was sort of a group effort across the company to build components and patterns and things as sort of needed ad hoc. A lot of people working on Google Maps were building stuff, Google Search, all those kinds of things. But material design had just started a nascent engineering effort to centralize a lot of that work. And one of the people who I often co-taught the Intro to iOS class, Alistair Say, he was working in material design and pulled me in. And Alistair is fantastic, but I miss him a lot, even though it's been 8 or 9 years now. But he pulled me in and started working on iOS components for material design. And that was kind of the very beginning. And then over time, I ended up actually taking over that team as tech lead and then as manager, managed that team for a little while, and then jumped to be a sort of overall tech lead of all the different platform teams. So at that point, Material had invested in engineering across web and iOS and Android and Flutter even. So I was sort of an overall tech lead for all those teams, trying to coordinate things and make sure that we did the same things at the same time. Maybe we released the same kind of components at the same time, that kind of work. And eventually moved into a different piece of Material where we were building out design tokens. So design tokens are, not invented at Google, but very common across the design world. But at Google, as you well know, it's its own giant ecosystem internally. And we needed to build some infrastructure, some database, some servers, some services, APIs to store and serve design tokens across all the different teams who need to use them. So I got to build that backend out, which was super fun. And I basically kind of went from more or less front-end and front-end thinking to more or less back-end thinking, which I really appreciated. It was a great opportunity at Google to be able to do that. And so built out the backend for design tokens and things. Still pretty involved in that world. I know a lot of the people working on it and I occasionally get pulled in to help out with things. And And more recently, I describe myself as a roving engineer. I am still within material design or our greater org, but I essentially get occasionally grabbed and thrown into a problem area and help out for 6 months or 12 months and then go and do some more troubleshooting somewhere else. So I kind of bounce around from hotspot to hotspot as required.
Okay. I know that near the beginning of the journey, you said that you did a PhD in computer graphics.
Yeah.
And then you said that you didn't really do anything with that information.
True.
One of the things that I'm really interested in on this show is like the ways that the different parts of the journey that like brings us all into the design world ends up showing up in our work.
Yeah.
So when you say that you didn't use the information, my first instinct was like, are you sure?
I'm lying. It's not true. I mean, everyone brings with them their background and their experiences. So, I mean, there are technical things. For example, I think Will Larsch was talking about color spaces a little bit, the HCT color space, and how we had to sort of invent a new color space to better represent what we were trying to do with personalization. And those sort of related technologies. And it was actually really fun watching that develop. I was chatting with some of the engineers at some point, but I did not personally work on that work. But it was really great to see a new color space come to be born. In the world, there are many color spaces, everything from like spectral stuff that, astronomers would use all the way down to some very simple things like RGB and everything in between, and it's been sort of slowly developing for, I don't know, 50 or 70 years by this point. But it's always exciting to sort of see a new one get born. I think the other thing that a PhD teaches you is perseverance. No one survives a PhD program without a lot of just, put your head down and kind of crank out a bunch of work and keep it going year over year over year. So that's something I feel like I did learn, and I have been very lucky to be on material working here for over 10 years now. But there's an element of that of trying not to bounce off of problems. When you find a problem, dig in and kind of sit with it and maybe sit on it and not just sort of like, oh, this is getting too hard. I gotta go do something else. Because we all have our various demands on our time. And sometimes it's easy to go pay attention to the other things instead of tackling that really thorny problem. I mean, so yes, although I'm not generating algorithms for, XYZ or anything like that. It's the kind of technical content of the PhD is now out of date. And I didn't actually use it in the sort of academic sense, which is what most PhD training really is. Right.
I know if colleague, friend of the show, Yasmin, is listening, she will know what you're talking about when you talk about committing to the problem over time, especially at Google. It's very like our plans are measured in centuries kind of vibe.
Yes,
sometimes.
100%. Also, hi, Yasmin. Yeah.
Shout out to Yasmin.
Exactly.
When you mentioned the color space specifically and like seeing a new color space get born, I think this is something we've had a few like really interesting articles that go into how the color space works and like what it allows us to do and things like that. But I'm interested in like why it's so exciting to see something like that come into the world.
That's a good question. I mean, from a design point of view, all of these color spaces and all of these abstractions change how you can look at things. Like, color comes from physics, and all the light that's shining down on us right now has all these wavelengths and all this sort of stuff. But that's almost like that's way too complex to handle in any kind of realistic sense. I mean, like I said, like if you're doing astronomy, sure. If you're doing chemistry, sure. But for people that are responsible for doing things like either color on screens, which is already a sort of limited slice of the universe, or color in printing. So that's another huge traditional place where color spaces thrive. or color matching, or I'm looking at a table right now, matching a color to the tone of this table or something. The color space that you work in is kind of like the language that shapes your thinking, about the problem. So it's exciting to see a new color space come out of a new set of requirements, really. It's a really interesting design problem, not because it's not software. I mean, I know there's software supporting it, but it's really a mathematical model, of what are the important parts of this giant, nearly infinite space of things. What is the most important parts of them, and how can we collapse those important parts down into like a set of numbers or, a set of smaller concepts or something like that, that make it useful and fruitful and convenient to use. So to see a new one pop up, first off, I mean, there are a lot of color spaces, and I would probably say 90% of them have, gone by the wayside. I mean, they just didn't survive in the landscape of competition of ideas. And so to see a new baby one come out and see where it's coming from, like why did we make the choices we did? Why did we need something new? Which is always a great question. That's an exciting moment. And I think it's probably too early to tell, but maybe, in 5 or 10 years' time, we can be looking back and maybe you're on the Wikipedia page for color spaces or something. And I really hope that, that one pops up. It'd be nice.
Yeah. We can talk about it again during the M20 campaign.
Exactly.
2034.
I can't wait. It's going to be great.
That is really interesting to me because it has so much to do with perception. And, you're saying like color is based in physics and stuff. We know that people will perceive colors differently. It brought to mind how working in engineering on a system at the scale of something like material, you are probably dealing a lot with finding ways to abstract perception to essentially like bring this subjective experience down into something more apprehendable, which is code or a mathematical model or something like that.
Yeah. And I think a lot of my work involves design systems, material design being the sort of parental design system at Google. But I don't know if everyone listening knows this, but there are many design systems at Google, and they're children of material design in a very literal sense. But like Maps will have their own design system, and Search has their own, and they're all born from material design, but they have their own local work to specialize to their domain, like a map or something. And design systems in themselves are an interesting abstraction of all the possible things we could do on a computer screen or on a phone. It's a really interesting and almost brutally hard problem to sort of think about. Like, really, when I'm looking at a laptop like I am right now, there's, so many pixels by so many pixels in a grid. They all can take on so many different colors. It could display pure static. We could display, rendered 3D shapes. We could do all sorts of stuff, but it's too complex to think about it that way. And not only for the designer and the person building the experience on the screen, but also for anyone trying to understand it and use it to get, real things done. So we boil things down. We create these abstractions, we create these systems, and in part of creating those abstractions and systems, we have to explain them to people, right? So I think this is where the storytelling and the visualization maybe part of abstractions like design systems come in, which is very interesting. So how do you explain, like, I sat down for 6 months. I figured out this great system of boxes and things on the screen that I think I can make word processors and podcast apps and whatever with, and it's great. But then how do you get that out of your head, that 6 months of hard work, and into the heads of people who have to build stuff on it, people who have to use it, all that kind of stuff. And for me, that's one of the difficult and interesting problems of building these big abstractions. And there's a shout out to the original material, actually. They had a beautiful just this beautiful way of describing it, that everything was supposed to be essentially cut out from pieces of paper. They were literal pieces of material, right? I don't know if you ever saw this, but the original material design, they actually took real paper, cut things out, and saw how the light and the shadows worked. And we have these great photographs in some of the historical stuff of them like setting up lamps on a table and casting shadows. And that's how they built the original interface components, by analogy, but sometimes almost just by copying these physical things. And the wonderful thing about that is that it's pretty easy to explain to people. Like we're all used to picking up pieces of paper and working with things and shadows and light and all that kind of stuff. Of course, it can go too far. You can go into the skeuomorphism, which is, I don't know, maybe entertaining, but not the most useful thing. And I think further iterations of material, M2 and M3 and everything that's, to come, have definitely wandered away from any kind of physical metaphor. But explaining that, we just spent so much time trying to figure out this system, explaining it to other people via a physical metaphor, that was brilliant. I thought it was really great. And I got to join the team actually it was just like a year-ish after the original release of material. And I remember being so impressed with this sort of like, oh, this is a very clear system. It was also very small and maybe not so tested at that time, had not hit up against the harsh bumps of reality as much, but it really was a very nice, clean system. So there's something in there about having an abstraction, not only having an abstraction that is useful and fits the problem space that you're trying to solve, but also is you can explain it to other humans. If you can't explain your abstraction to other humans, it's going to be really tough.
Yeah, it's interesting, this point of like consolidating all of these ideas and then needing to turn them so that they come back out and kind of like spark the same imagination in other people. A previous guest on the show, Judith Donath, who's done a lot of work on social computing and topics of the interface and things like that, said that metaphor has kind of always been one of the fundamental ways that we explain things that people have not encountered before.
That makes sense.
Obviously, we see that reflected like in the original version of material. It had like an extremely strong metaphorical basis to the point that, yeah, you're right. Like there's videos of like Christian in his garage with floodlights and these paper rigs. But the system has really evolved since then. And I think that like one-to-one metaphorical basis is no longer there. And I wonder, one, how important you think that metaphorical basis is in today's context, and two, if you think that the software interface is something that has become so established that we don't need to rely as much on metaphor to explain the fundamentals as we might have 10 years ago.
Yeah, 100%. The initial problem of explaining how to use something to people who did not grow up with it or are not familiar with it is like real, and probably something that happens all the time. I don't know, like maybe self-driving cars are having this problem today or something. Certainly anything to do with AI, we're having that problem today. No one has any clue of how to like hold or handle an AI thing right now. It's, all over the place. And I think with original, metaphors like the desktop metaphor, I think you've talked about before, the sort of paper material type thing for original material. All these things are familiar, make things comfortable, hopefully make it understandable enough that people can make leaps based on what they know about things and have it applied to the actual digital imaginary interface. So they're very useful that way. But I think as people get more and more used to this and are like literally born into, like the cell phone era and things like that, we are given the freedom to wander away, and it's okay. People don't get mad. They, I think the skeuomorphism thing is really interesting. I'm sure there's people who study that, academically and in interesting ways, but we just don't design things with faux wood grain and things that look like, a podcasting app with a little microphone and stuff like that. because partially I think we don't need to anymore. We don't really need to spoon feed users on these concepts, at least, because they grew up with them. They know how to use them. They're pretty familiar with them. We no longer have, in high school courses that teach people about how to use a mouse. Although I'm sure maybe they're still typing. I don't know, but we don't really need it anymore. So it allows for more freedom of expression, which to me is exciting, but also you could wander too far afield. You could, your design UI elements or whatever could get too abstract or maybe too inconsistent. So like, I think, as you know, working on a design system, one of the important things is to make it as consistent as possible, to have some principles, whatever they are, and have those shine through everywhere in the design system, in the UI elements and how they interact. So I think you sort of run the risk of like, it gets too floofy, it gets too abstract, it's no longer holding together. And then, what do we got? I don't know, sort of falls apart.
Yeah, that's an interesting point, that actually so many possibilities are opened up that you need to create kind of your own pocket world that holds some internal consistency so that people can build a model of how this works.
Yeah, I love that. One of my friends is a faculty of game design, actually. His name's Andy Nealon. And we talk about, we play games together. We've been playing games together for a long time, before he was a professor of games. But we play games together, and we often talk about sort of video games are really interesting because people aren't surprised that they have to learn the interface every time they sit down with a new game, right? You sit down with a new game, and honestly, if it's a console game, you probably know how all the buttons work. If it's, a point and click thing, you probably know how most of this works. But there's always this tutorial phase, this opening phase where you're like learning, oh, that's where the jump button is, or I don't know, there's no jumping in this game. Fine, I have to figure other things out. And people aren't like surprised or shocked or bothered by that. So it's a really interesting sort of, you said pocket world, I think. Every game is a little pocket world for UI design, but also, physics and, because in games they can do whatever they want. So physics and interactions and how characters interact. Do you speak to people? Do you not? Who are the bad guys? Who are not the bad guys? All that kind of stuff. I find that really interesting because it feels like, sometimes it almost feels like I can see the original like game designers sitting there and going like trying to talk to me telepathically through the design of the game, right? They're not there in the room to say anything. And sometimes you get frustrated with it. You're like, why did you put this thing that looks like I can jump on it, but I can't jump on it? Like what are you doing? And I sometimes wish I could have that conversation with the original game designer. But I love that idea of a little pocket world of interface or something that can explain how to interact with things. That's great.
So in recognition of that kind of possibility, does that then make the task of kind of engineering or engineering leadership even more difficult when you have like such a broad range? Because I know on material, I've seen folks draw things or animate things that, are brilliantly far away from anything that we know to be possible in the physical world.
Yeah.
So I can imagine that looking at something like that and bringing it back down into the system can be intimidating.
Intimidating is one word for it. Yeah. There is forever a tension between design and engineering. And ideally, it's a creative tension that great things come out of, but sometimes it's a little tricky. And motion, I think, actually, it's a good example, is one of those places where we have not done well enough in the world of UI design. There have been so many great, like sort of, I'd say, micro design systems of motion about, when you interact with this, it does a certain thing, or maybe tunable. So we could have something that's more hyperactive. We could have something that's more calm and enterprisey. And they rarely get kind of well translated when you get down into the code and the implementations and things. And it's a really tricky kind of balance to make because the designer is designing well, ideally not in a vacuum. No, I mean, a designer's job is to not, necessarily be in a vacuum. They're bringing all their experience and all their, world knowledge in with them. But in the end, they're not designing typically by writing code on an Android device. That's just not kind of how the process works. So they design some motion, some awesome, whatever bouncy thing. Sometimes an element in isolation, will have motion, but maybe we're not thinking about, okay, that's one button on a crowded screen of all sorts of stuff. How does that, maybe that makes the button, I don't know, overlap other things. And that's tricky. I think one thing that's interesting about being an engineer is in the end, your job is to make it all work. And so engineering is often left figuring out a lot of the little details and the little problems that either were not thought of, or maybe they were thought of but not documented, so we're not dead sure of what we're supposed to do. So it's an interesting, the transition from design to engineering is a really interesting one. And ideally it's working very well, so you've got a designer and they sit next to your engineer, the dream. You've got a great designer sitting next to a great engineer at the literal table, and they're bouncing ideas back and forth. Oh, this doesn't work. Oh, this does work. Great. Let's do this. But in reality, in these large company settings, design is designing a thing, kind of packaging up and maybe putting a bow on it, and then handing it off to engineering for feedback, or maybe even just final implementation. And then the feedback starts coming. Oh, this doesn't work, and that doesn't work, and this doesn't work. And, if there's enough time, that actually rounds off the sharp edges of the whole thing, and we end up with something that's better. But I don't know if that's always the case.
Yeah. We talked earlier about how our entire team basically is collectively speaking to the outside world and perhaps many teams within the outside world. And it's our job to kind of consolidate all of these ideas into some form of communication that then comes back out and helps everyone understand what it is that they're using that we've produced. And I'm kind of seeing a smaller version of that playing out among teams who might have to do certain parts of the work asynchronously, from design to engineering. How do you convey the rationale in a way that sparks the same understanding in other people that you had when you made the thing? I think it's the same also when I work with another designer, when I work with an engineer, when I work with an editor. It's not only, here's the thing that I want to do, but also, they might say, here's how it breaks. And then I have to say, okay, here was my intention. What might we do in order to resolve that?
And I think that, the hard problems are always the human problems. And I think one of the hardest things is communicating intent, like you said.
Mm-hmm.
And I think one of the good things, we're talking about Material 10 here, coming back to either the original material design or its current incarnations, I think one of the greatest things about it was that we had all of this written guidance about how it's intended to be used. It's not just a sticker sheet of all the button variations and slider variations or something. It's trying to explain, this is what we were thinking, this is sort of how we think these things go together, all the way down to do's and don'ts for using a button, that kind of stuff. But communicating that intent, especially when you're not there or can't be there because of geography, because of time in the way that maybe you did all this work and designing all this stuff, but we decided not to build it just yet. And then 18 months later, we're like, cool, now we have time to build it. And, that was 18 months ago. So there's barriers to communication sort of everywhere. And I think it's really tough because it's hard because your intention, and maybe you had a beautifully fleshed out model in your head of how all this hangs together and stuff, and that's great. But if it didn't get kind of written down and recorded and in some form that, say, an engineer can understand, it's not. I don't want to say it's lost, but it's going to make the job way harder. It's a really interesting and I'd say permanent problem. Like, I don't think AI is going to solve it for us. I don't think anything's going to solve that for us as long as there's people collaborating on something, especially people with different backgrounds. So I would, in an ideal world, I would love every single like UI designer to have engineering experience. And I would love every single engineer out there to have to go through a design sprint and a design crit and all that kind of stuff. In reality, we know that's not really the case. So without that shared background and experience, I mean, you are an exception, sir, but without that kind of shared background and experience for both sides of the process, it's really tough. Like, the language is different, the metaphors are different, your training was different, all of that. It's a hard problem.
Yeah. So Design Notes is going on record as saying designers should code.
Designers should code. And I mean, engineers should design. I would be super excited to see that. Yeah.
Totally. Yeah, I think there was a really interesting point you made about the, about the original material design spec, which was that there was so much of the intent behind the system embedded in the way that it was described there. And that resonates with me because I feel like over the years I've heard over and over again at I/O or just online or wherever that those specs were a lot of people's, including engineers, first introduction to design, period.
100%. Yep.
And I wonder, like, the system has made some major shifts over the past 10 years with personalization, tokens, like new technical complexities, more components. We're at a point now where I feel the system is actually quite powerful in the way that it abstracts things. And I think we also face a challenge in conveying that same level of intent in a way that comes out to the overall audience out there. And I'm curious what you think about that. As we grow in complexity, how do we keep explaining or keep embedding that knowledge or building that model?
Yeah, that's a great question. I know, for instance, material design, the sort of the public spec that we have up on the web is used in a lot of design curriculum, which is great. It's such an amazing thing that someone's like teaching off of this or using this as a resource in the teaching. I think it's super cool.
Shout out to Austin and Barbara and Megan and Euphrates and the whole team.
100%. I am extremely lucky to sit with some of those folks. My desk is right next to all of them or a bunch of them. And I'm a lucky guy. I'm a lucky engineer. The complexity question is really interesting and really hard. So like in software, there's a very, well understood, not solved, but well understood problem of systems that grow over time, right? So if I'm creating, let's say I'm creating a 1.0 of a mapping API. So I can, you can hit this API and ask for, I don't know, the coordinates of the closest coffee shop, and it will spit back something, whatever. You can imagine some kind of API. And at the beginning, it starts small. It starts tight. Every different API entry point, every different call you can make follows the same patterns and the same like error responses and all this kind of stuff. And that's about as tight as it's going to stay at the beginning, right? Because over time, say your API gets very popular, or maybe it's a product, maybe it's being sold. You get these feature requests. Certainly bugs will show up. You miss something. We're all human. But you get feature requests to build on it. You start adding more things, and we all try to stay consistent as much as possible. But again, being human, we're going to fail. And sometimes there's serious business concerns, like if you're at a startup and if you don't add this in the next 3 days, we might all go down, so over time, the complexity of the interface grows. Even if it's with the best of intentions, the more and more and more we add to this thing, it gets heavier and heavier and kind of creakier and harder to understand. And I think this is a very natural result of successful systems, any kind of system. And a lot of the time, at least in software, they, you can see this in open source projects, actually. You've got it's so common. You've got some very well-known library, say it's a mapping library or something, and it's had a 1.0, now it's up to 1.7, whatever. It's had many iterations. but it's getting creaky. And somewhere at some point, someone is going to say, you know what? I'm going to rewrite it. Like, we're going to start the 2.0 project. And it, open source, it causes this schism in the community. And there's people that, no, keep the original. No, I want to build this new thing. And they try to start again because basically the complexity gets too high to make progress. There's something similar in terms of, you've probably bumped into this, in terms of software teams who maintain a product. So at the beginning, I've got my product, maybe I've got 10 engineers, great. And we're adding features at one feature a week or something, great. But then the size of your project or product is growing. So the number of feature requests and bugs and the maintenance involved grows and grows and grows until the point you get to some point where the product is so big that the maintenance cost is 10 engineers. And at that point, you will never add another feature because it has grown to the size of the team who supports it. And, then you got to do something drastic to fix that. I've gone far afield of your original question, I think.
No, but it's good because I'm also wondering, obviously maintenance is one thing that I've bumped into over the years, but also I'm curious about code as a constraint, or like the complexity of the system becoming a constraint, in the sense that, no spoilers, but I've proposed features for existing components that, the components are built in a certain way in a library that people are actively using, and certain new behaviors would make it really hard to kind of build that component in the way that it currently exists. So where design runs up against what is possible with what is built, how do you think about resolving that? How do you know when the balance of changes that you would have to make in the way that the code is built is worth it?
It's a good question. So I would say software engineering in general is a game of trade-offs, right? It's always, we can do anything, almost anything. Software engineering is a kind of wild world these days of there's a lot of magic. It seems like magic probably from the outside, and of course there's a billion constraints on the inside, but within those two, bounds, there's a ton of room to build things in many ways. So like you said, you're, let's say, to be concrete, you're proposing a new animation style for an existing button but that button is used in a couple hundred places in every, let's say it's internal, every Google app. Great. How many Google apps are there? I don't even know, but there's dozens is too small of a number, right? So that button is being used everywhere, and you want to add this new motion constraint to it. But the original authors of the button weren't even thinking about motion. They were just like, oh, well, we know what the right motion for the button. It goes, I don't know, click, click, or something like that. And they have no concept or no ability in there to add anything new in terms of the motion curves or whatever it has to do. At that point, that's a big trade-off, right? So you have one designer who has worked very hard and has brought all of their knowledge and training to bear against some problem. And their answer is, okay, cool. What we need to do is add this new motion curve to this button. That's like 100% cool. And that is exactly why, designers are awesome. And that's why they're there. And then we have all these engineers who are responsible for, shipping this button and getting into the apps and all the bugs that come back and all this kind of stuff, who are saying like, yeah, that's cool. But for us to change this, say, several thousand instances of this button everywhere, it would take us, 6 months of work or something, especially at something the size of Google. And then someone has to balance the trade-offs between the benefit that new thing would bring against all that engineering time. And one thing I will say is a lot of engineers, especially if they're not haven't been design adjacent and haven't worked with designers tightly, I think a lot of engineers sometimes have this sort of crusty response of like, no, I don't want to change anything. Like, it's working, leave it alone. Why are you changing my buttons, basically? We get this all the time in material design. And I respect the position, but I think it's also a little short-sighted sometimes. And and someone needs to, bridge the gap between those two, and ultimately make a call. At least in an organization like Google, in a startup, I'm sure you could do something a little bit more agile. The trade-offs are there, but the scope is smaller. I don't think there's the tension between those two things is never really going away. And I don't know. I mean, the answer is always like shove everyone in a room and make them figure it out. Get the humans talking to actually talk about it. But yeah, making those kinds of changes is very hard.
Yeah. I think definitely at previous jobs I've worked with software engineers who like the first reaction that I get from a proposal is like, that simply isn't possible.
Yes.
And I think something that we have mostly gotten the hang of on the design side is answering every question with, well, it depends.
Yes. Well, it depends.
I think that's ultimately the answer to everything.
Yeah. And to come back to what you were saying before, that these are imaginary people we're making up here, but that engineer that says that simply isn't possible, maybe with this kind of like slightly dumbfounded, irritated view look on their face, like they're thinking of the abstraction, to go back again, the abstraction that has sort of been built into that button, say. It's I can change the I can change the font, I can change the color, but no, there is no way for me to change the motion curves, or no, there's no way for me to change the corner radius or something. And of course there is, in the sense that it's all software. I mean, you can rip things out and get pretty low down in the stack if you have to, but in their heads, their day-to-day conception of that button, which exists for a very good reason, they have that conception for a very good reason, that their day-to-day conception of that button doesn't include these affordances, the motion and the corner radiuses and stuff. So for them in that second, like it's a true response, like it's a real, like, I don't know what you mean. Like, this brick is a brick. I don't know what you want me to do with this brick. It's what's going on here. But the one thing that's exciting about software development is that you can disassemble the brick. You can bring the brick down to its component atoms and start again.
Right.
To kind of bust this analogy badly, but I like that kind of reaction of like, oh, that's impossible, because you can clearly see at what level does their level of abstraction sort of stop, or what's their working concept.
Yeah, there's a concept. Again, like I have a background in sociology and art, so I approach design from that perspective a lot. And I think one of the things that we're talking about here, which I think we've been talking about the whole time, is the concept of intersubjectivity, which is basically like person A has a perception of a phenomenon. In this case, it's like the button. That is their like model and informed the way that they built it. I also have my own model of the button. But intersubjectivity is like knowing how to have a perception of the other person's perception, how to orient yourself towards that person's mental model of the button, which I think is what we're talking about when we talk about how engineers need to have a design perspective and designers need to have an engineering perspective. We need to understand how each person is kind of modeling the same concept in their mind, because it's not the same, going all the way back to the beginning of the discussion with perception and color.
Yeah, I honestly think it's like it's one of the biggest challenges in life, like I've got it's the biggest source of, or a big source of misunderstandings in life. I don't know. I've got a certain sense of like how clean the apartment should be. And maybe your partner has a very different sense of how clean the apartment should be based on like how they were raised and like, I don't know, stuff that they see. But if you don't ever talk about that, you're going to just be butting heads continually. It's similar. I mean, luckily for design and engineering, one nice thing I think actually be about this problem in a work context is that as long as everyone is respectful and cool and trying to, in general, do the right thing, the way around this is, like I said, is we all sit down and ideally in the same room physically, but, in the same virtual room, and kind of talk it out. And then I learn your model and you learn my model. And I love being in some of these problem solving sessions where we're like, no, we can't add motion to this button. It's impossible. I absolutely love, you can see the light go off in someone's eyes when they're like, oh, wait, you want to do what? And then you can see them finally mapping the two models together.
Yeah.
And figuring out what you wanted. And then usually it goes fast. And it's like, oh, cool. Yeah, we can do this. We can do this. It goes from there.
I feel like we've had a breakthrough on this episode. I feel like designer-developer collaboration is unlocked. I feel like this makes it, like, this perspective on things makes it such a more apprehendable problem. It's not something that's unique to our work environment or our roles within that environment. It's actually just what we're doing all the time, every day.
Yeah, 100%. It's just been professionalized, and I often think about the training we all got. Like I didn't get trained as a designer. It sounds intense. I've never been through a design crit, despite me claiming I should do that. It sounds intense. Designers who came up through sort of a traditional training also didn't stay up all night in the engineering lab, like getting whatever done. There's different cultures, kind of bumping up against each other. And ideally that is rich and fertile and everyone is excited to learn about their coworkers, how they're thinking, all this kind of stuff. Sometimes time pressures and geographic differences and time zone differences and stuff leads us to butting heads a little bit more than it should be. I hate the standard curmudgeonly engineer thing of like, oh, well, design just designs these wild things and then throws them over the wall. And now I got to learn how to build them, or figure out how to build this thing. I really dislike that because, design is amazing. They do amazing stuff. They're also humans who sometimes mess things up or don't understand, say, like, really common things like my phone needs to run at 60 frames per second. That is the standard set by the system. And if it doesn't run at that, like, there are severe consequences. Therefore, there are real constraints on your motion curve or whatever. But designers can grok that. And then, we can get better together. But
also like, get over here. The wall is not endless.
Exactly.
Come over to this side and I'll do the same.
Yeah.
I want to wrap up, ostensibly we're here to talk about the history of the design system, the past 10 years, all of that stuff. But I also want to take all of that information that we've just talked about and get your idea, your extrapolation into what's going to happen next. What do you want to happen next?
Sure. So I see a fork in the road. I'm sure you see a similar fork. And the fork in the road is this. We have the juggernaut of AI bounding towards us. Obviously, Google and many other companies are working very hard to figure out how AI might solve real problems. But in terms of user interfaces, one branch of the road is this sort of, I would say, I guess now traditional UI design paradigm, right? So we work with designers, they come up with design systems, we come up with color systems and motion systems, and we codify them into design tokens, which then get shipped to engineering, and engineering uses those things to build experiences that turn into apps. That's sort of, I actually don't see that changing too much. There's a different branch in the road that I've heard people talk about, which is my phone or my app or something will basically become an empty container. And then AI will, on the fly, based on my needs and my preferences and what I'm asking for and stuff, ship UI down the wire or down the radio waves into my phone. And the phone's UI will, update spontaneously based on the current task and this kind of stuff. So sort of a fully AI-driven, real-time UI. I am having a hard time imagining that second branch of the road being sort of practical, but it is totally possible I'm wrong. But the future, as I'm seeing it right now, is a little fuzzy, as is many things with AI. I have a hard time imagining a fully AI-driven UI But I would be excited to be wrong. And I think the more interesting part will be, how does new technologies like AI or whatever's coming next modify the traditional design and engineering workflows? So, for example, one thing right now is designers, at least at Google and in many other places, are the ones who have to go through their design systems or go through their designs and pull out the design tokens, right? They need to pull out, the primary color is FFF, the something else is something, something, something. And then they kind of either input those into a program or write them down in a spreadsheet or whatever the workflow is. And somehow those get transformed to code. It's all sort of dependent on your environment. Maybe that's a place where something like an AI could help extract that step and basically make it transparent, like make it to the point where we kind of engineers consider like a compiler or something. It's just like, oh yeah, I don't even think about all the machinations that are happening to extract that stuff. And it works almost perfectly, or perfectly enough that I can forget about it. And that would be like, if we get, those are the interesting bits. How do we make these technologies actually help the sort of human process? I'm hoping we don't end up in some spot where all these new technologies are like eliminating the human process, because I think that would be a giant loss and kind of lame and boring. But it's possible. I don't know.
The optimistic, perhaps naive part of me thinks that humans are always going to be human processing.
Yeah.
I don't know how that could be replaced. I think if humanity has no creative motivation, then we're like living in a different dimension.
Yeah. I think some humans will always be doing the creative stuff. I worry about how many of them can pay rent doing so with some of these technologies coming down the pipe. I don't know. It's, let's say, uncomfortably exciting. We'll see where it goes.
Yeah. For my part, I have to say, another thing I did when I was in school was glass blowing, and my professor was really good friends with an artist who worked in Venice, and he had a big studio, and he had many people who came out of that studio to start their own studios. And one student in particular ended up copying one of the teacher's most iconic works and kind of selling it. And people always ask this guy in interviews, they said, like, aren't you upset that one of your students is like ripping off your coolest piece or whatever? And the guy was like, no, it doesn't bother me, because I think people who encounter this work will always know the difference. And I do think it's the same for the interface.
Yes.
We will always feel the difference.
Yes. These things that have high touch, literal touch, but high, we're experiencing them pretty deeply, I would say, or at least uniformly through the day and regularly and stuff. I agree. You definitely feel it. It's like font selection in books or something. Sometimes you pick up a book and you're just like, oh, nope, not reading that, because I don't know what the heck that font is. I don't know if it registers like consciously. But yeah, I agree. We're very sensitive to these things.
Thank you again, Adrian, for joining me. This was a really cool episode.
Yeah, thanks so much. It was really fun to be here.
You can subscribe to Design Notes on Spotify, Apple Podcasts, or wherever you're listening right now. If you like this episode, leave us 5 stars and stay tuned for more interviews with the founders and stewards of design at Google as we uncover new histories, perspectives, and futures for the interface. As always, thanks for listening and sharing.